class. I've received a few questions about this problem. This is section 4.1, number 87. You'll find some similar to this in your homework. What it's asking you to do is to solve a system like all the other ones in 4.1, but it has a little bit of a difference because the variable's in the denominator. So it tells you sort of how to work around that situation. By using the concept that P equals 1 over X and Q equals 1 over Y. So what we're basically going to do is we're going to get rid of the variables in the denominators, solve the system, and then bring that concept back. So this is what it looks like. In our first equation, our goal is to create this 1 over X so that we can plug P in for it. So right now I have 3 over X. So to convert it over, all I have to do is put the 3 out front as 3 times 1 over X. Notice those are the same. If I were to multiply that, that would get me back to 3 over X. Same concept for the second one. We have 4 over Y. Again, I want to move that 4 out front, and that's going to give me 1 over Y. The 5 over 2, nothing wrong with that. There isn't any variables or anything, so we keep the 5 over 2. Go ahead and try to do that same process with the second equation, and probably need to pause me for a second and then start me back up. Alright, hopefully you've had an opportunity to try that. So what we're going to do is this time there's a 5 on top, so I'm going to take the 5 out, and that's going to leave me with 1 over X. And my second one, notice that there was a negative, so make sure you have a minus 3 that you removed out. And that's 1 over Y. And we're left with 7 over 4. What we've done so far is manipulated our equations into the form so that we can actually do some substitution. So what we're going to do is, instead of 1 over X's here, I'm going to want to plug in a P. And instead of 1 over Y's here, I want to plug in a Q. So what that looks like is my first equation. It's going to be, instead of 3 times 1 over X, it's 3 times P, plus, instead of 4 times 1 over Y, it's 4 times Q. And again, we're still okay with the 5 over 2. In my second equation, again, I want to get rid of the 1 over X for P. That's going to give me 5 over P minus 3, get rid of the 1 over Y for Q, and that equals 7 over 4. Okay, so what we've done so far is we've taken our equations and we've manipulated them into a form that we're comfortable with, which is the 3p plus 4q equals 5 over 2, and the 5p minus 3q equals 7 over 4. Okay, so now let's go ahead and solve those like we've been solving them before. So I'm going to extend this a little bit. So I have 3p plus 4q equals 5 over 2, and I have 5p minus 3q equals 7 over 4. Well, since I have my p and my q's lined up, I'm going to use elimination here. You could look at maybe doing substitution, but notice none of our variables have a 1 in front of it, so it is going to be a little more challenging to do the substitution. So elimination is what we're going to choose. Okay, so what that requires me to do is I'm going to have to try to get the same number, opposite sign in front of either the p or the q by multiplying. I'm going to pick to work with the q's just because they're already opposite signs. So one of the steps is already done for me. And now I need to figure out, well, what can I multiply 3 and 4 to get to the same number? It's almost like finding a common denominator. So between 3 and 4, I would be going for 12. That's the first number they both have in common. So to get from 4 to 12, I multiply by 3. And to get from 3 to 12, I multiply by 4. So remember, we need to multiply all the way across. So that's going to give me 9p plus 12q equals, this becomes 3 times 5 over 2. Remember, there's a 1, so when I multiply, it gives me 15 over 2. In my bottom equation, multiply by 4, that gives me 20p minus 12q. Again, we're multiplying the top here, so 4 times 7 gives me 28 over 4. Okay. The idea with elimination is once we have the same number opposite sign, we're going to add them so that one of the variables eliminates. So in my p's, I have 29p when I add those. The q's are going to give me 0. Equals, I need to add these two. Before I can add fractions, I have to have a common denominator. So the common denominator between 2 and 4 is 4. So I multiply this by 2, which gives me 30 over 4 plus 28 over 4 gives me 58 over 4. Okay, so I found common denominators and then I added the two fractions. To solve for p here, we can either divide by 29, but since I have a fraction over here, I'm going to write it as multiplying by 1 over 29. That's just going to reduce a little better. Multiplying by 1 over 29 is the same as dividing by 29. On the left side, these reduce, leaving me with just p. And then 58 and 29 reduce. 29 goes into 58 twice. And then I can go ahead and reduce 2 over 4 to 1/2. Okay. So we have one of our variables, which is p. We need to find the second one by plugging it back into one of our equations. I'm just going to pick the first equation here. So I have 3p plus 4q equals 5 over 2. All right, so I'm going to take this 1/2 that I just found, and I'm going to drop it in. Remember, if I'm going too fast, you can always pause and slow me down. So this is 3 times 1/2 plus 4q equals 5/2. This gives me 3 over 2 plus 4q equals 5/2. We solve for q, subtract the 3/2, subtract the 3/2, and that gives me 4q, the q, equals 5 minus 3 is 2 over 2, which equals 1. Divide by 4. And we get q equals 1/4. So we have q equals 1/4 and p equals 1/2. half, if I remember correctly. Yes. So P equals 1/2, Q equals 1/4. So we sort of feel like we're done, but remember we did that little bit of manipulating at the front, or at the beginning, where we said P was equal to 1 over X, Q was equal to 1 over Y. So what I need to do is plug that back in. So I had Q was the same as 1 over Y. So I have 1 over Y equals 1/4, because I want to know what Y equals. P equals 1 over X from the beginning equals 1/2. And then we can go ahead and cross multiply since we have a fraction equal to a fraction. So when I take Y times 1, I get Y, and 4 times 1 gives me 4. X times 1 gives me X, and 1 times 2 gives me 2. So that tells me the solution to my system is 2, 4. So this is definitely a lengthier process than solving just a regular system of equations where we don't have variables in the denominator, but it does require you to do a lot of the same steps in the middle. The only difference is at the very beginning, we need to change our format, get rid of these fractions, and make them into our P's and Q's. This portion of solving a system, very similar to what we've already done. The last part is identifying, well, now that we have what Q and P equals, we want to bring back the values. So Q was 1 over Y, P was 1 over X. Solve for X and Y, and we have our two solutions. Hopefully that was helpful. Let me know if you have any questions.